Welcome everybody to the Flying by the Seat of Our Pants Bird Festival. This is the second presentation, and tonight's presentation is by Jessica Griffiths about why birds flock. Can't wait for this. This is going to be a really interesting one. Before we get started, I've got a few announcements, and the first one is, as you have heard, we will be recording this video, and it should be on the website later on this week if we can get our act together. Again, we are flying by the seat of our pants. So there are a few normal Zoom functions that we are not going to allow tonight. The first one is everybody is muted, because you know, when you got a few hundred people in the Zoom room and everybody starts chatting, it's just a mess. So you will be muted. We also will not be recognizing the raised hand function, so just don't even bother to use it, because we're not going to recognize it anyway. And now, as for the chat function, that's a handy function, and we will use it to ask questions of the presenter. So if you have specific questions for Jessica, go ahead and use the chat function. But you know what? Let's wait until we hear what she says first before we start asking questions, because when you see that chat thing going on and off when you're the presenter, it can be distracting. So just wait for a few minutes as we get into the show. The last thing I really want to say is, you know, we've had to cancel our in-person festival kind of at the last moment. And so if you would like to see an in-person program again, we're going to need some donations. Now, these Zooms are totally free. We're not going to charge you to see them here or to charge you to see them on the website. But if you could donate, it'd really be helpful for us. Even though we're all volunteers and we don't get paid for this, it does take money to put together a bird festival from scratch. So you can help donate by the old-fashioned way of writing a check, which I don't know if I remember how to do that, and putting it in the mail. I don't know if I could find a stamp for that either. But if you want, on the last slide, we will have some QR codes. You can hold up your phone to make a donation by PayPal or Venmo. Now, if you're going to donate over $299, you're going to have to choose the PayPal one, because Venmo has a limit of $299. Also, if you just don't remember all this, go to the website. There will be a link. You can push the donate button. Now, and I want to talk a little bit about Jessica Griffiths. She's been a working field biologist for, I don't know, over 20 years or something like that. In fact, probably today you were out counting butterflies someplace. I'm not sure, but I've seen some posts on you and Monarchs. I hear that you grew up in Chicago and got your undergraduate degree there at Wesley College outside of Boston, and spent some few years traveling in the country working for nonprofits and government agency in several states with a focus on songbird ecology. In fact, I hear you're pretty good at bird songs. Maybe you could even do a presentation of that later this week. That would be pretty cool.
I might.
You work for Ventana Wildlife Society, doing some ornithology things in the Big Sur lab. You've discovered a passion for public outreach and education, and you've given presentations on wildlife to thousands of people. You got a master's degree at Cal Poly, our local university here, and there's something about butterflies. Maybe you could mention that just before you get into your program.
Sure.
So it is really nice to have you here, Jessica. I can't wait to hear what you have to say about flocking birds, as you're right now leaving flocking butterflies to come and join us.
Okay, well, thank you. Yes, so I volunteer for an organization called the Xerces Society, which conducts an annual survey of all the monarch butterflies on the coast of California. And so I've been counting butterflies like crazy in November, and then again at the beginning of January. So I personally have counted, I don't know, probably over 75,000 butterflies this year. It's a lot. But tonight we're going to talk about birds flocking together. So without further ado, I'm going to just go ahead and get started. So we're going to do a PowerPoint presentation. So I will get that going. And here we go. Hopefully I'm sharing the right screen. Okay, there we go. You guys should be seeing my title screen there. So I'm going to talk about why basically birds of a feather flock together, and maybe why birds of some different feathers flock together. I will say the alternative title for my talk was What the Flock, but I thought that was maybe a little inappropriate. So instead it's Why Birds Flock. So let's go ahead and just jump right in. Okay, there we go. So flocks are really a unique spectacle of nature, and they can be huge and dazzling, like this flock of starlings. They can be loud and maybe kind of annoying, like a flock of crows or ravens. Or they can be beautiful and mysterious, like a flock of geese flying across the moon. Flocking birds have really captured our imagination for a long time. But why do they actually do it? You know, what is the science behind why birds flock? Well, let's talk about the basics, really. Okay, why would birds even want to be together in a group? It really kind of comes down to costs and benefits. So some benefits of flocking together include cooperative foraging, so birds can look for food together. They can share information about the food they find or about predators or dangers in the area. There's also, of course, safety in numbers, you know, many eyes looking around for predators. It can be easier to find a mate when you're all together. You don't have to travel as far. But of course, while there are lots of benefits, there's also costs. So that includes increased competition for food. You know, every bird is trying to get as much food as possible, and those flock neighbors can be competition. There's also a higher risk of disease when animals are in close proximity to each other. It makes it much easier for disease to spread. I think we've all learned a lot about that the last couple of years. As well, there's a risk of increased aggression between birds. You know, if they're trying to get the same bit of food or something, you could get into a scuffle. So there's that. But really, all birds are accountants at heart. And so it all comes down to, do the costs outweigh the benefits? So for birds that do flock together, those benefits are greater than the costs. So today we're going to talk about why and how birds form flocks, and we'll discuss a few of the main reasons that they do. So we're going to cover migration, foraging, communication, and safety today. So let's go ahead. So first we're going to talk about migration. Now, when most people think of flocking birds, they think often of the typical V-shaped flock of migrating birds. So why do they do that? Okay, well, generally, birds that flock together during migration are those large-bodied birds. So we're talking geese, ducks, cranes, swans, large birds like that. Large birds are heavy and they need extra lift. So really, it's all about energetics. That V formation actually generates lift for birds flying staggered behind the wingtips of the bird in front. So each bird flying behind the leader is doing less work. That means the bird in front is doing a lot of work, but then they can switch. So if you've ever watched a flock of geese traveling across the sky, you may see that that bird in front kind of drops back and a new bird takes its place. And so they can kind of share the load. But really, riding on each other's wingtips, it's kind of the same principle as cyclists riding each other's draft. You know, if you think about Tour de France, how all the cyclists are lined up behind each other like that, it's the same principle. Birds can save up to 40% of their energy by flocking in this very specific formation. So really early research, 20, 30 years ago kind of identified that birds were saving energy doing this, although we didn't really know exactly how that was happening. So there was a really great a researcher with the last name of Portugal and his colleagues. They studied northern bald ibises. And honestly, I think these birds have a face only a mother could love. They're just sort of delightfully garish looking. So what they did is they actually raised a flock of bald ibises from chicks. And they raised 14 juvenile birds, and they trained them to follow a human flying a light plane, like a glider plane. And every bird was fitted with a backpack containing a specially built GPS unit and an inertial measurement device. And that you can see in this picture, the bird is getting fitted with its special backpack with its equipment. And that inertial measurement device measured, the precise location of the bird, but also the speed the bird was traveling and when and how hard they were flapping their wings. So we're talking like really detailed data. And this is actually a video. It might be a little bit choppy, but this is a video that they filmed. So this is the person flying in the plane is shooting their camera off, and you can see all the ibises flying after them in a row. And I will hit play and we'll see if this works. So it's a little bit choppy, but you can see the birds all flying behind them. In the lower corner, that's the tire of the plane there. So just kind of a fun visual. And what the researchers found was actually really fascinating. They found that the birds changed their pattern of wing beats based on their position. So we have this little diagram here. And what this shows is that when the birds were flying in a staggered position, right, not one behind the other, the bird in behind would synchronize its wing beats with the bird in front. That maximizes the beneficial sort of upwash capture, okay? When the bird was flying directly behind it, the bird behind was alternating its wing beats with the bird in front. That's called basically anti-phasing their wing beats, and that avoids the downwash. So these birds were changing the way that they flew in order to maximize the benefits of flying that way. They also saw that while some birds like to fly, on one side of the V or on other side of the V, really they moved around a lot inside the flock. So they didn't necessarily have a fixed spot that they stayed. They also had to learn how to do this. So these juvenile birds did not know right away that how to change their wing beats like this. They had to practice, and there was no adult bird to learn it from. They actually were learning it from each other because they were following a human on a plane. So that is a learned skill that they had to practice. So very cool. So next time you see birds flying in a V formation, you'll know just how much work they're doing and kind of how much mental processing it takes for them to save energy. Okay, let's talk about foraging and flocks and foraging. So one of the most important reasons to join a flock is to improve foraging success. That means that birds in a flock will have better luck finding food. And there's lots of reasons for this. So one is they can learn from each other. So foraging birds will watch the other birds in the flock and actually learn the locations of like hidden food items or a good technique to use. So say they're foraging in a tree and one bird discovers that there's like bugs hiding underneath the little ends of bark. Well, other birds will notice that bird going under the bark and they'll do it too, and they'll be more successful. So they can learn from each other. They also will individually spend less time watching for predators. And so less time watching for predators means that you have more time to search for food, which means you find more food. And last but not least, they can grab like a prey item like an insect or a lizard or something, or some other piece of food that was either flushed up by or missed by another bird. And a great example of this are ground hornbills. So these are these large birds in Africa. They walk along the ground. If you can imagine people walking in a row to sort of beat the bush and flush prey out, well, ground hornbills do the same thing. And every bird that scares up, a lizard or a big insect or something, they're not going to necessarily grab it, but another bird in the flock can. So they can kind of forage, more efficiently when they're all working together like that. Okay, another really fun example of cooperative hunting is great white pelicans. So I'm here on the central coast of California, and we have great white pelicans here, and they will actually forage in a really cool way. They will form a circle and they will open up their bills, and they'll surround a school of like small fish or other prey, and they'll sort of all tighten the circle, open up their bills and scoop up the fish. Almost like they're drawing closed, a net or a trap. If anybody has ever seen footage or read about humpback whales fishing using bubble nets, this is a little bit of the same kind of concept. So they're all working together to get the prey in the middle, and then they scoop it all up. I love this picture because you can see the cormorant in the middle there, just hanging out in the sweet spot, like just ready to snap up any fish that the pelicans leave behind. So up until now, we've actually just been talking about flocks composed of only one species. You know, we've got that old saying, birds of a feather flock together. And that's rooted in the observation that most flocks of birds are made up of the same species. However, in fact, though, lots of different kinds of birds will actually flock together. They can and do form what we call mixed species flocks. And a lot of these mixed species flocks are formed for the purpose of foraging or looking for food. So therefore, we call them mixed species foraging flocks. It's a little bit of a mouthful. These are, as I said, flocks comprised of multiple species, and they allow the birds that are members of these flocks to have increased foraging efficiency, kind of for the reasons we already discussed, you know, less time being vigilant and learning from the other birds in the flock. Now, what's interesting is that these flocks are often led by what we call a nuclear species. That species attracts the other birds to the flock and leads the flock. Okay, now, when I say nuclear species, I don't mean like a bird that was exposed to like radiation or anything. Okay, no, I'm not talking about that. What I mean is nuclear in the sense of a nucleus. So that is a central flock species that the other birds kind of follow. Nuclear species around the world where you see these mixed species foraging flocks, these nuclear species have the same characteristics. They're gregarious, which means they're really social and they like to form flocks. They have conspicuous, easily identifiable plumage. They're mostly year-round residents, which means they're there all the time and they don't migrate away, so they're there year-round. And they have a really easily recognizable alarm call. So here on the central coast of California, the nuclear species that leads our mixed species foraging flocks is the chestnut-backed chickadee. This bird is a permanent year-round resident. When the breeding season is over in the summer, they will form these social flocks, basically in the late summer, fall, and winter. They have these very bold facial markings. You can see the really recognizable black and white, and they have really loud, recognizable calls. So they are the perfect nuclear species. So why do birds join a mixed species foraging flock? Well, migrating birds have a really serious dilemma. They are often passing through and stopping over in areas that they are not familiar with. So these birds might have never been to this place before that they're migrating through, and they don't know a lot about this area. Okay, so think about this. How do you find food in an unfamiliar place? Okay, think back before there was cell phones and Yelp and all that kind of stuff. If you went to a new town, how would you find the best place to have dinner? You would ask a local. Well, that's exactly what these migrating birds are doing. So it's beneficial for migrants to join flocks led by resident birds because those local resident birds, they know where all the food is. They know what kind of food is in the area. They know where the water is. They know what kind of predators are in the area. So it's just so much easier for those migrating species to join these flocks of resident birds. It's really beneficial, and it benefits those nuclear species, right? The chickadees get a boost because now there's lots of other birds to help them look out for predators. So here on the central coast of California, there's lots of birds that sort of typically join these mixed species foraging flocks. I put up some pictures here. So Wilson's warblers, yellow warblers, Pacific slope flycatchers, downy woodpeckers, warbling vireos, Townsend's warblers, the list goes on and on. I mean, literally dozens of migrating species have been documented in these mixed species foraging flocks here in Central California. And for those of you that are birders, I know, like me, a lot of times a great way to find an unusual or vagrant migrating bird is to go check these mixed species flocks, right? In the fall, go find a chickadee flock because you might find a crazy warbler in there. You never know what might be in one of those flocks. Now, what's really interesting is that mixed species foraging flocks are all over the place. And in Central and South America, those foraging flocks, actually, the bird species have evolved matching colors. That's how important these foraging flocks are. And these matching colors, they might serve as sort of a badge that increases acceptance by flock members, or they might even function as kind of like a uniform that aids in recognition of those sort of, quote, friendly flock species. Like all the birds wearing those colors, they know that those birds are not predators, they're part of it, they're going to benefit the flock, so they can recognize each other. In the mountains of Western Panama, the flock uniform is black and yellow. So there's actually a ton of species that have these black and yellow colors, which all flock together, but I picked 6. But you can really see how these birds are all color coordinated. Yellow-thighed finch, white-naped brush finch, etc. So really, really neat. In the South Central Andes, team colors are blue and chestnut. So here, these birds, these species all flock together, and it's a way that they can recognize each other. And there's tons of other examples of this in like specific regions of Latin America where, you know, in this specific place, these birds that flock together have these colors. So that just shows you how important those mixed species foraging flocks are. Pretty neat, I think. Okay, I am going to touch very briefly on communication, and specifically communication at communal roosts. So one reason that birds may form a flock is in order to provide information to each other. So this picture I have here, for many of us, this is probably a familiar sort of fall and winter sight. Dozens or even hundreds of crows gathering together at the end of the day and then all flying to a roost together. So research has shown that when birds like this, especially crows and ravens, when they form these large roosting flocks, they are actually communicating with each other. So information exchange at the roost has been documented. There's a researcher named John Marsluff, and he's spent decades researching corvids, crows and ravens, and has done a lot of work with ravens. He's also written a couple of really interesting books about crows and ravens. And he discovered that birds that have knowledge about food will communicate that information to other birds at the roost. So for instance, ravens that discover a carcass one day will actually the next day go back to the carcass, and they will bring other birds from their roost with them. And naive birds, he actually conducted an experiment where he had like ravens from another area where he released these birds who did not have knowledge of the carcass at the roost. And then the next day, those birds follow the ravens to the carcass. So somehow the birds are communicating to each other like, hey, I found this like sweet carcass, you guys, like we're gonna feast, everybody, you know, in the morning, everybody follow me. So they are giving information to each other. So pretty neat. Okay. Last but not least, I want to touch on one of the most important reasons that birds flock together, and that is for protection. So this picture is of a peregrine falcon swooping on a flock of European starlings. So this photo was taken in the Central Valley of California. The photographer is named Nick Dunlap, and I'm going to have a bunch of his pictures in the remainder of the presentation. So flocking for safety. Okay, the really big reason that birds flock together like this is the increased chances of spotting a predator, right? So the more birds there are in the flock, more birds looking out for predators, and each bird can then spend more time foraging or sleeping or preening or doing whatever it needs to do, and less time being vigilant and looking for predators. Also a benefit is that if one bird sees a predator, they can sound an alarm, and all the birds in the area, not just the birds in that flock, but all the birds can get warned. So it really just benefits everybody. A great example of this is actually ostriches. Ostriches must keep an eye out for lions because that's what actually hunts them. There's not much that can catch an ostrich, but a lion is pretty much their main predator. So at any given time, you know, one or maybe two birds are playing lookout while all the others can have their heads down foraging. You can see that in this picture. And there's actually another great example of a local bird species here in central coastal California that we often see conspicuously posted up on a fence post or maybe a shrub, looking out for the rest of the flock. And I can't take, you guys can't shout it out, but the bird I'm thinking of is California quail. So California quail, you'll very often see one bird sitting up high, keeping a lookout. They will take turns watching out for the flock, and this allows each bird to spend more time foraging. So if you spend time watching a quail flock, you will actually see them kind of like a changing of the guard, where you might have one or two birds, sitting up high, and then after a little while, they'll drop down and other birds will take their place. So that basically allows all the other birds to spend much more time just, relaxing and finding food. So what happens if a predator does come in, and try to get those birds in a flock? Well, they will initiate evasive maneuvers, and this is something really cool to see. Lots of different kinds of birds will do this: starling, shorebirds, swallows, all different kinds of birds. So if a predator gives chase, the birds in a flock, there's a lower chance of any one individual getting caught by that predator. And birds that are separated from the flock, those are the ones that are most likely to be eaten. So as long as the birds stay with the flock, they have a much lower chance of getting killed. So that's another benefit for them. And I just have a series of photos here by this photographer, Nick Dunlap, of peregrine falcons, pursuing these flocks of European starlings. This was all shot in the Central Valley of California. So you can see there's the peregrine falcon coming in from the upper left, and you can see the birds have formed this tight ball. That would be a real challenge for any falcon to pick out just one bird in there. And here now we can see the falcon is kind of this tiny speck. It's kind of a slightly larger speck on the right side of what looks like almost a tree or a chimney, kind of swooping in. You can see where the starlings have formed the kind of this dense, crazy formation to evade. And here's a close-up photo, just this wall of starlings. The peregrine will be really hard pressed to select just one bird from this. So the starlings are, really doing themselves a favor and increasing their own chance of survival. Okay, so we see these flocks, these birds moving, almost as if they have one mind, swirling and keeping so tight together like a school of fish. How the heck do they do this? Well, to be honest, this was actually a really big mystery for a very long time. How birds do this? How do they move in unison? It seems like no lag time between, when a bird turns and its neighbor turns. And I have to say, there were some pretty crazy theories. Some of my favorites include natural telepathy, thought transference, biological radio, or perhaps disembodied electromagnetic consciousness. I mean, people truly had no idea. I mean, they literally were proposing that maybe the birds were somehow psychic. So we really had no idea until a really awesome study that was done in 2014. So a group of Italian researchers led by I'm going to butcher his name, Atanasi. They worked in Rome, and they filmed starling flocks in Rome with these high-speed cameras, and then they used this really sophisticated tracking software to analyze the movement of all the birds. They generated paths for the birds, and we're basically using these supercomputers to kind of crunch all the numbers. And what they discovered is that each bird is tracking 6 or 7 birds around them, in their immediate vicinity. And what they're doing is when their neighbor turns, they're not visually trying to copy the direction the bird is flying. Instead, they're copying how sharply their neighbor turns. So it's almost, they don't even have to think about it. They're basically just turning when their neighbor turns. And what that means is the message to turn basically starts from just a few birds, maybe those birds closest to the predator. And the message to turn sweeps through the flock at around 20 to 40 meters per second, or 90 miles an hour. And what that means is a flock of 400 birds takes half a second to turn. So it's really incredible. And I will say this, the math equations that they use to describe these flocking birds are actually almost identical to what they use to describe the movement of like supercooled liquid helium. So, I mean, they were doing like physics style equations to figure this out, but that's basically what the birds are doing. So they're just responding to like essentially their neighbor's spin rather than their neighbor's direction. So really interesting. And that is how you get these truly remarkable flock formations. So that is pretty much it. We've sort of gone through everything I want to talk about, and we've got about 15 minutes for questions. So I will stop sharing my screen and I will take any questions that you guys may have. I obviously didn't cover everything that there is to talk about with bird flocks, but I will delightedly take any questions you have that, you know, we're in the chat. I don't, let's see. Okay, oh boy, here we go. Questions are starting to come in.
Hey, Jessica. Okay, go ahead, Jessica.
So I'm getting some questions sent to me, so I'll just go through. So first question, is that amazing flock movement only for evasion? And basically, yes, that is the primary purpose for these movements. However, I will say that researchers have observed birds like starlings will actually do kind of slower, more kind of graceful flock movements at sunset. So the birds all come together to go, basically to go to bed, and they'll kind of swirl together in these what they call murmurations, these big groups. And the purpose of that is actually less clear. They're not doing evasive maneuvers, but it could be a way to strengthen their bonds, or, you know, there could be some other communication that's happening there. But the really crazy sort of tight, like when they're all like turning really fast, you know, that's really only used for evasive maneuvers. Okay, and I'm gonna, lots of questions coming in. Okay, question, is it always male quail on watch? Not always, but primarily. That a lot of times it is the male being vigilant. However, I've definitely seen female quails posted up. So it's not exclusively male, although mostly males. Where in the Central Valley can starlings be viewed? Oh my gosh, I don't even know how to answer that question. I mean, they are everywhere. They're here, they're there, they're everywhere. Anywhere that you have really large, like industrial size, like ag fields. And I will say this, those big starling flocks are primarily in the winter. So the flocks will break up in spring and summer so that the birds can go off and, you know, they form pairs and they'll get a territory and they'll raise a nest with young. So like late spring and summer is not a great time for flocking, but late fall, winter, so like this time of year is when you get the big flocks. And we do have flocks of starlings on the Central Coast. I've definitely seen them, although we don't seem to get the huge flocks you see in the Central Valley, because the Central Valley has like huge fields of crops that we don't have on the coast. That's primarily what they're feeding on. But I have seen like down in Santa Maria and like up around Salinas, like so in our ag areas, we definitely get big groups of starlings. Okie dokie. Are there any examples of young birds new to evading flying into other birds? I'm positive. It's definitely not perfect all the time. They do crash into each other. So that's definitely a risk, right? When you're in that tight formation, is that you may have a clumsier bird who knocks into other birds. It definitely happens. I know in that paper where they were filming all the birds flocking in Rome, they did see some collisions, so it definitely happens. I do think, though, that the clumsiest birds probably get maybe eliminated before they can reproduce. So it's definitely not a trait that's selected for. Why do birds not flock? Great question. You have some species that don't flock, and for that particular species, if you remember that at the beginning, we had that cost versus benefit slide. So there are some bird species where it just doesn't benefit them to join a flock. I can think of, let's see, a lot of, I mean, we do have a lot of birds that do, but like, for instance, birds like warblers, they tend to not form flocks comprised of like all the same species of warblers. Instead, they will join mixed species foraging flocks. Birds like jays, you don't really usually see like large flocks of jays. You will see family groups. So you'll maybe see like 4 to 8 jays together, but they don't really form these big, you know, foraging flocks either. They don't really need to. So yeah, okay. Okay. We had a question actually about the ethics of that ibis experiment, which is a really good question. Is it ethical to have had the airplane leading the juveniles without their parents? And I believe that the reason that they did that was because for sure those researchers would have gotten like all the permits and all the stuff to ensure that, you know, and actually that's a great question. I don't know if those birds were then like releasable into the wild, or if they're now just part of like a, you know, if they went to a zoo or something like that. But they would have needed to have parents not involved. They want to train the birds to follow the researchers so that they can dictate exactly where the birds are flying and for how long and the direction and everything, and to get all that data. Okay. Do they flock a certain way for protection, like young birds in the center or old birds on the outside? That's a great question, and not to my knowledge, although I don't think anybody's actually looked at that. Are the mechanisms of evasive maneuvers similar to schools of fish? So fish are actually using, fish have can sense electric fields, and that's actually how fish are flocking, is they are sensing a mild electric charge in the water. And so the water is a really good conductor. So that's actually how schools of fish are turning. So birds can't use this. They actually use a totally different mechanism than fish, even though it looks the same. Let's see. Why can't the peregrine just pick one bird off the edge of the flocks? Do they always go away hungry? Well, 9 times out of 10, they do go away hungry. It is very difficult because the bird on the outside of the flock is always changing. I didn't show any video. I was just showing snapshots where it kind of looks like, oh, there's obviously a bird on the outside. But if you watch video, you can actually go to, if you guys go to YouTube, you can type in like starling flock, you know, and there's all kinds of really cool videos, and you can see how it's really changing and how it would be hard for a bird to go hone in on one bird. Gosh, okay, wow, okay, I'm just gonna start. What proportion of species in tropical mixed species flocks have similar colors? That's actually a great question, and I don't know. I believe that definitely not all of them. So I think that only in very specific areas do you have this phenomenon. So like, you know, I couldn't actually tell you the proportion of flocks, but I know it's not every mixed species flock in the tropic is going to have this cool like uniform phenomenon happening. Let's see. Oh, a question about wind turbines. Once we have wind turbines off the Morro Bay coast, will birds adapt quickly to flying above or around? That's actually a really great question. Definitely some birds will, you know, birds are smart and they learn where obstacles are. However, I will say the technology to keep birds and bats away from turbines has actually really progressed and is actually really, really effective now. So you have things like basically like electromagnetic fields, like high frequency pitches, like lights. There's all kinds of stuff. Lights are actually really important too. There's all kinds of stuff that we can put on turbines to keep birds away. What else? Oh, somebody put a question/comment about pigeons. Yesterday I saw a flock of pigeons continuously turning. So that's a great observation. Pigeons are definitely another bird that flocks in, you know, generally you're not seeing massive flocks of pigeons. You might get, you know, 20, 50, maybe 100 birds in the city. And they will be sort of like wheeling around. Pigeons are really social. And so sometimes it could be that they're flying to avoid, you know, either they got scared by something like on the ground that caused them to flush up and now they're kind of flying around. Or it could be that they're searching for a place to land. It could also be just like a social behavior. I will say I definitely don't know all the inner workings of the pigeon mind, but there's lots of different reasons that they could be flocking and flying like that. What is known about how flocks, quote, decide where to go to sleep? That's also you guys are just full of really good questions. I believe it's basically a group choice. So, however, birds will go where other birds are, right? So the birds will find a place that is safe or secure, and a lot of times they will then return to the same roost. This is very true of crows here in our area. It's like the same, not only is it the same throughout the season, but it's the same roost year after year. Like the crows will like all go their separate ways. They'll breed during the summer, they'll have their kids, and then in the winter they come back and they're using the same roost. So a lot of times sort of a tried and true place they'll come back to. But flocks, depending on the species, small flocks like chickadees actually do have sort of what we would consider a, quote, alpha pair, in that you have one or two pairs of birds that are kind of like the leaders and sort of making the decisions about where the flocks go. I'm not really sure if crows or ravens have that same social structure, and to my knowledge, starlings do not have that social structure. Instead, it's really just like sort of mass, it's like groupthink, right? Which maybe groupthink is bad, but anyway, they are deciding kind of together where, and it'll become clear if a roost is safe or not safe, you know. Okay, what else? Boy, lots more questions. Okay, I've got what, 4 minutes. We have wild parrots in San Francisco. I have seen them flock. Is this typical? Yes, definitely. Parrots are very social birds, and where they are native. So I cannot remember what parrot species. I think there's actually multiple parrot species in the Bay. There's also parrots, naturalized parrots in Southern California too. And yes, they will naturally, wherever they're from, if you go to, you know, the tropics or Australia or whatever, where they have parrots, you will see them in flocks. They are highly intelligent, highly social birds. So yes, that is typical for parrots. Oh no. Somebody made a comment. Yes, fireworks that scare roosting flocks of diurnal birds have caused them to crash into each other in the dark and fall to the ground. Yes, so that's actually one of the reasons that, you know, human disturbances can be really problematic for birds, particularly in these roosts. You know, they've gone to bed, it's dark, and they don't necessarily see super well in the dark, depending on the species of bird. So things like fireworks can definitely like flush them up, cause them to collide with each other, or collide into buildings. So yeah, that can definitely happen. And okay, I think that's about it. I know I didn't get to everybody, but you guys just had great questions. That I felt like that was like the lightning round, where I was like boom, boom, boom. So thank you guys so much, and I'm going to kick it back to Chris.
Okay, Jessica, that was really good. I think the thing I liked most was, you know, I'm not sure about the responding to neighbor spin. I really like the disembodied electromagnetic consciousness.
There's kind of something also awesome about that, isn't there?
Yes, and I also like the team colors in mixed flocks. What a great concept. I really like that. There was one question about monarchs. Do the birds have any effect on monarchs? Could you touch on that one way or the other?
Yes, super quick. Monarch butterflies have a natural defense against predator, which is they eat milkweed when they're caterpillars, and milkweed has a toxin that makes them taste really bad. And so the adult butterflies also taste really bad, and actually that's why they are black and orange, because it's actually a warning coloration saying, I taste bad, don't eat me. And birds, unfortunately, they have to eat one butterfly to learn that it tastes bad. So there's a little bit of, you know, attrition. Individual butterflies will have to like take one for the team. So generally birds don't have a huge impact on monarchs. However, there are a few species that have learned how to eat just the fat deposits in the abdomen of the butterfly and avoid most of the bad taste. So things like kingbirds, chickadees, towhees, and scrub jays will all eat monarchs, but they generally don't eat enough to make any kind of a dent in the population. So wow. I hope that answers the question.
That's crazy. Thank you for that last question. As we wrap up, I really appreciate your talk on the flocks. I'm looking forward to your talk later on, a couple of days, about the birding by ear. That's going to be wonderful. I wanted to let everybody know, if you didn't get your question to Jessica in time, just email to support@morrowbaybirdfestival.org, and we will get that question to her. That will be on the last slide as we go there in a couple minutes. A couple other things just to let you know. We had 250 to 300 people in these last couple rooms. We have Zoom rooms that will hold 1,000 people. So go ahead, get on your social media, invite everybody you know, because we want everybody to come tomorrow. Tomorrow at 11 a.m. is Kelly Vanden Heuvel with Pacific Wildlife Care. Then we have Sarah Killingsworth, a pretty amazing photographer, doing a double session on advanced bird photography. That should be really interesting. Then we have Steve Bessinger on black rails. I can't wait for that. And then we have Steve Schubert on the history of peregrine falcons at Mora Rock, which will be amazing. And then after that, we have Brian Sullivan. He will be doing the Cornell and eBird stuff and what's going on. Mark mentioned a couple things there, which was really cool. And then tomorrow night, the icing on the cake tomorrow night is John Muir-Law's a double session on the habits of, actually the successful was supposed to be cross out, is habits of happy birders, because successful birders, I don't think you're ever going to be a successful birder, but maybe you can be a happy birder. So that's the lineup for tomorrow. Remember our donations options. If you can donate through this screen, there's the donate by Venmo on the left and PayPal on the right. If you can't pull that off, go to the Morro Bay Bird Festival website and you can click on the link right there. Again, thank you for coming. We are so glad you joined us, and please share with your friends. We'd love to share as much as we can with this Flying by the Seat of Our Pants Bird Festival. And come back tomorrow. The show starts at 11 a.m. and we'll see you there. Just come in a couple minutes to make sure you get your seat. And we'll see you tomorrow, everybody. Bye-bye.